Hello there, grade 7 learners. How are you doing? It's me again, Teacher Kat, and welcome to our Math 7 o'clock. I will be joining you for this week's lesson, which is angles and angle pairs. This is under the week 2 third quarter lessons of our Mathematics 7 class. So I hope that you are all ready and you are very much excited with this topic. So what are we waiting for? Let us now start the discussion. Okay, before we proceed, let us know first what is our target. So with this session, you should be able to derive the relationships of geometric figures using measurements or by inductive reasoning. You should also be able to know the supplementary angles, complementary angles, congruent angles, vertical angles, adjacent angles, linear pairs, perpendicular lines, and parallel lines. So it's quite heavy, but I know that you can do it. Just listen and be focused. Okay, so since our topic is all about angles and angle pairs, I am expecting you that you should have your previous knowledge or stock knowledge about angles, just like what you have discussed in your elementary days. So this time we will be having a quick review of these concepts regarding angles. So as you can see, I have here jumbled letters, and all you have to do is to rearrange them so that we can form terms involving this. So these words might include angles or its different parts or the different types of angles that you know. So are you ready? Okay, that's great. So I will be giving you 5 seconds to answer each jumbled letter. So the first thing, here's our first set. We have the letters L, A, G, E, and N. So what do you think is the term behind these jumbled letters? Okay, time's up. So if your answer is angle, you are correct. So angle, what is an angle? Sometimes they are reading it as angle, but you can use or you can read it whatever you want, but please be careful with the spelling. It is A-N-G-L-E. Now, what is an angle? So when we say angle, it is formed by two non-collinear rays with a common endpoint. So we are talking of two rays here with common endpoints. So how are we going to visualize or illustrate that? Let's say, for example, we have here a ray AB, and then so the endpoint of ray AB is point A, and then we have another ray which is ray AC. So as you can see, the endpoint of ray AC is point A as well. So point A therefore is the common endpoint. So this angle or this figure is an illustration of an angle, and we can name it as angle BAC. Okay, so we can write it or name it as angle BAC. I'll repeat, this is angle BAC. Or you can also name it as angle CAB. Okay, so let us have the next jumbled letter. Okay, what is that? If your answer is acute, you are correct. So acute, we are referring to acute angles. So what is an acute angle? An acute angle is the angle that measures less than 90 degrees. So here is an example of an acute angle. So we have angle XYZ, which measures 75 degrees. Since 75 degrees is less than 90 degrees, that is considered as an acute angle. What do you think is the next type of angle that we are going to discuss? Okay, so we have the following jumbled letters. Okay, time is up. The correct answer is right, and we are referring to the right angle. So, right angle is an angle that measures exactly 90 degrees. And an example for which is this one, and it has a symbol. This symbol, the square one, that is a symbol that tells us that angle is a right angle. ABC, angle ABC is a right angle. Okay, we have the next. So we have these jumbled letters. Okay, I hope that you have your answer right now. So if your answer is obtuse angle, you are correct. So obtuse angle is an angle which measures more than 90 degrees but less than 180 degrees. Okay, an illustration of an obtuse angle is this one. So we have this angle which measures 120 degrees. Since 120 degrees is greater than 90 degrees but less than 180 degrees, it is considered as an obtuse angle. Okay, let us have the next one. Okay, time is up. This one is straight. In some books we are having this straight angle, but in some books they do not have this one. So sometimes we are using this straight angle to show an angle that measures exactly 180 degrees. So since it is from the word itself or from the term itself, it is straight. So that means that we are having a straight line. Okay? So the measurement is 180 degrees. If we have, as you can see, we have here a straight line. Yeah. Okay, that is a straight line from this one to that one. So we have a straight line. Okay, let's have the next, or straight angle. Let's have the next one. The next jumbled letter is an illustration, or is a term that refers to an angle which is more than 100, that measures more than 180 degrees but less than 360 degrees. And that angle is known as the reflex angle. Again, I repeat, reflex angle is an angle that measures greater than 180 degrees but less than 360 degrees. And it looks like this. Okay? It is always greater than a straight angle. So since we have 220 degrees as a measurement, that is already considered as a reflex angle. So I guess and I know that by this time, you have recalled and reviewed the different types of angles and different terms involving angles. And I'm pretty much sure that with this, at this point, we can now proceed to our next part, or to the next part of our session, which is all about angle pairs. Okay. So angle pairs, from the word itself, pairs, we will be talking about pairs of angles. So expect that we have we have two pairs, or we will be talking about two pairs or two sets of angles. So the first the first angle pair that we are going to discuss is the adjacent angles. So when we say adjacent angles are angles on the same plane that have a common side and a common vertex but no common interior points. An illustration of an adjacent angle is this one. So we have, as you can see, we have here angle ABC. Okay, I get here. There. So we have here angle A, B, and C. And then with this angle B and C, we can see this line or this ray BD. Okay, and this ray BD divides angle ABC into two parts, wherein these two parts are called adjacent angles. Angle A, B, and D, and angle D, B, and C are called adjacent angles because they have this common side. Again, we have adjacent angles if we have a common side for both angles. Is that clear? So this time, the common side, or in this illustration, the common side is ray BD. And we have two adjacent angles, and these adjacent angles are angles ABD and angle DBC. Is that clear? Okay, we will now have the next. We have the vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. Take note of that. Two intersecting lines. And they are non-adjacent. So when we say non-adjacent, they do not share common sides. And always take note that all vertical angles are congruent. So we have here an illustration. Okay, as you can see, we have this intersecting line, and then we have another line here. And then these intersecting lines form four angles. Namely, we have angle 1, angle 2, angle 3, and angle 4. Okay. So we can say here that angles 1 and angle 3 are vertical angles. They are opposite. Okay? There. And then we also have angle 2 and angle 4 are also vertical angles. All opposite angles are called vertical angles if we have intersecting lines. And since it is stated here that all vertical angles are congruent, that means that angle 1 is congruent to angle 3 and angle 2 is also congruent to angle 4. So if the measurement of angle 1 is equal to 70 degrees, that means that the measurement of angle 3 is also equal to 70 degrees. Is it clear? And if the measurement of angle 2 is 110 degrees, what would be the measurement of angle 4? Okay, very good. That is also 110 degrees because they are vertical angle. If you have or you can identify vertical angles, automatically it is or they are congruent. Let us have the next one. Okay, we have the complementary angles. So complementary angles are two angles. Take note that we are always talking of two angles whose measures have a sum of 90 degrees. So in symbols, if we are going to add, or let's say for example, we have angle A and angle B, and let us assume that these are complementary angles. If they are complementary angles, that means that their or the sum of their measurement is 90 degrees. Let us have this illustration. Okay, we have here angle F, E, and D. And we have adjacent. Is it an example of adjacent angle? Okay, very good. This is an example of an adjacent angle because we have two angles, angle FEG and angle GED. Okay, we have angle GED. They are adjacent because they are sharing a common ray, which is, or common side, which is side GE. And we all know, as we can see, the measurement of angle FEG as given is 60 degrees. And the measurement of angle GED is 30 degrees. If we are going to add this, the total or the sum is 90 degrees. Since the sum of these two angles is 90 degrees, this means that they are complementary angles. Okay? If it is not equal to 90 degrees, it is not complementary. Okay, let us have the next illustration. So we have here separate angles this time. We do not have adjacent angles anymore. We have separate angles. We have angles TUV and angle XYZ. So angle TUV, the measurement of angle TUV is 45 degrees. On the other hand, the measurement of angle XYZ is also 45 degrees. I have a question. Are these two angles complementary? If your answer is yes, you are correct. These angles are complementary. Why? Because if we are going to add 45 degrees and 45 degrees, the total is 90 degrees. So therefore, angle TUV and angle XYZ are complementary angles. Okay. So let us have here more examples. Okay, for example 1, let us assume, this time I am going to write an example. We have here a given wherein I have angle 1 which measures 45 degrees, and then I also have angle 2 which measures 50 degrees. Now, I have a question. Are these two angles complementary? Are they complementary? Alright, very good. If your answer is no, you are correct. They are not complementary. Why? Because if I am going to add these two angles, the answer or the sum would be 95 degrees, which is not the measurement or the requirement for complementary angles. Therefore, angle 1 and angle 2 are not complementary angles. I have next, we have example 2. Let's say, for example, it is stated that angle 1 and angle 2 are complementary. They are complementary. But then, it is also given that the measurement of angle 1 is equivalent to 30 degrees. What would be the measurement of angle 2? What do you think is the answer for this one? Again, I will repeat, angle 1 and angle 2 are complementary angles. It is also given that angle 1 is equal to 30 degrees. What is the measurement of angle 2? What is your answer? Okay, let us see. Since angle 1 and the measurement of angle 2, the sum is equivalent to 90 degrees, applying the rule in our algebra, the 90 degrees minus, you have to subtract 30 degrees from 90 degrees. And therefore, the answer is 60 degrees. Okay, that means that the measurement of angle 2 is 60 degrees. And to check our answers, let us add 30 degrees and 60 degrees. If that summed up to 90 degrees, we are correct. I hope that with this simple computation, you can now answer simple problems involving complementary angles or involving angle pairs. Let us now have the next angle pair, which is the supplementary angles. Supplementary angles are two angles whose measures have a sum of 180 degrees. For complement, do not be confused with supplementary and complementary angles. When we say complementary angle, the sum is 90 degrees, but if we are talking of supplementary angles, it is 180 degrees. Let's have the next or the figure here. So we have here adjacent angles again. We have angle M and O and O and P. And as we can see, they have the same side. That makes it adjacent. So the measurement of angle M and O, the measurement of angle M and O is equivalent to 135 degrees. And the measurement of angle O and P or P and O is equal to 45 degrees. So if we are going to add it, that is equivalent to 180 degrees. So therefore, these angles, angle M and O and angle P and O are supplementary. Okay, let's have this one. Okay, again, we have separate angles. We have angle ABC and angle TSR. The measurement of angle ABC is 60 degrees and the measurement of angle TSR is 120 degrees. So if we are going to add them, is it equal to 180 degrees? Okay, correct. The sum is 180 degrees. 120 plus 60 degrees. The sum is 180 degrees. That's why it is considered as supplementary angle. I hope that you can follow. Okay, so yeah. For example 1. Okay, so for example 1, we have here, if I have angle 1 which measures 100 degrees, and we have angle 3 whose measure is unknown, but we all know that they are supplementary. If they are supplementary and angle 1 is equal to 100 degrees, or the measurement is 100 degrees, what would be the measurement of angle 3? Okay, so to solve for this one, simply subtract 100 from 180 degrees. Okay, and since 180 minus 100, the answer for this, or the measurement of angle 3, is 80 degrees. Is that clear? Okay, I have another example. The measurement of angle 5 is 150 degrees, and the measurement of angle 3 is unknown, or angle unknown. But again, it is given that they are supplementary. So how are we going to do that? Okay, so all we have to do is to subtract the measurement of angle 5 from 180 degrees. Okay, so we have here 180 degrees minus the given, which is 150 degrees. So therefore, the measurement of angle 3 is 30 degrees. I hope that you can follow. Okay, let us have the linear pairs now. When we say linear pair, a linear pair consists of two adjacent angles whose non-common sides are opposite rays. So linear pairs are also or always supplementary. Again, These are the characteristics of a linear pair. A linear pair must be adjacent angle and they should be supplementary. Adjacent angle, that means that they should be sharing a common side. So to illustrate that one, we have here an illustration. We have angle VXY and angle ZXY. As you can see, they have here this one. This is straight angle here. If we are going to combine them, they are going to form a straight angle. So if we have that case, if we have two angles, that if we are going to connect them and they form the straight line, it is a linear pair. Take note that they should share a common side. Is that clear? So all we have to do, so this is all what we have for this session. I hope that you have learned something. If you want to try and to have more activities and more discussions about our lesson, you can have the following references. You can search it online and you can consult your teachers for this one. Okay, if you have questions, you ask your teachers or you can comment your questions below. Again, I am Teacher Kat and this ends our math session for the week. Goodbye and God bless everyone.